anyway. Okay, yes, under boiling / evaporation, do add the following extra words, yeah. Boiling occurs at a specific, so write down the boiling point. And the point of pure substance is a specific temperature. Okay, occurs at a boiling point. Who knows what is the temperature, the boiling point of water?
100 degrees Celsius.
Okay, so so simple, 100 degrees Celsius for water. Does that mean that every other substance will boil at 100 degrees Celsius? If
No.
water boils at 100 degrees Celsius, is that true for all other substances also?
No.
No, yeah, no, because different substances will have its own specific boiling point. It's just that water is specifically 100 degrees Celsius. Understand? Okay, so that is for boiling. Yeah, make sure you write this down now. Now, I also want you to write down something about evaporation. Write this down. Occurs at all temperatures. It is a slow process. Evaporation happens very slowly, and it only happens at the surface of the liquid. Okay, so write that down. Occurs at all temperatures, slow process, and occurs at the surface of. Okay, so whereas boiling, right, it actually happens throughout the entire liquid. Evaporation only happens at the surface of the liquid. Okay, guys, write this down and then you let me know once you are done. Okay, as you're copying down, can you try to remember from P5, P6? What are the different factors that will affect the rate of evaporation? Does anyone remember? Different factors that can affect the rate of evaporation. Anyone recalls? What will affect rate of evaporation? Zakia, Abdullah, any idea? You see, do you remember not? Anything about what affects rate of evaporation? Is anyone there? Can someone answer me?
I think like one of the things is surface area.
Yes, very good. One of the factors is surface area. And if you remember, there's also things like the presence of wind, right? And then also the temperature of the surroundings. Yeah, all these things will affect the rate of evaporation. But please note that boiling and evaporation are two different processes. Boiling happens at a specific temperature and it's higher than the temperature at which evaporation occurs, because evaporation occurs at all temperatures. It is a slow process and evaporation only occurs at the surface of the liquid. Okay, is everyone done writing these extra stuff down in your assessment?
Yeah.
Done, huh? Okay. What about the other two of you? Abdullah is done.
Yeah.
Okay.
Yeah.
So we have melting, boiling, evaporation, condensation, freezing. I want you all to also note, yeah, the temperature of melting and freezing is technically the same. The temperature for boiling and condensation is also technically the same. The only difference is whether you are heating it or cooling it. Okay, so melting, boiling are heating processes, whereas condensation and freezing, they are cooling processes. So can you just then also write down somewhere in between melting and boiling evaporation, right? There's a tiny space there. Just write down processes so that it is heating processes. Then at the bottom, in between freezing and condensation, there's a tiny bit of space. Okay, in between and slightly below that, you can write down cooling processes. Just so that you know there's a difference between these two. Right? Who knows an example of a substance that undergoes sublimation? Those of you who attended last week's lesson, you would know some substances that can undergo sublimation. Sublimation is when a substance changes from solid to gas immediately. Any recollection? What is a substance that can undergo sublimation? Is something that we put inside our cupboards to prevent insects and moths from ruining our
Mothball.
clothes. Very good. Mothballs, yeah. Mothballs. Who, I think I've asked this before, but has anyone seen a mothball? They kind of look like white and pink and green little balls, and they kind of look like candy. Anyone seen it before? Mothballs? Anyone? No? Okay, so yeah, mothballs are very important, yeah, because they basically help to kill um moths, eggs, and larvae that sometimes can be nestled within our cupboards, because our cupboards they tend to be very dark, right? And sometimes also quite damp. Those conditions are actually quite conducive for insects and moths to lay their eggs and then grow. And the thing is, moths can actually, feed on the clothing fibers. Okay, and it can ruin our clothes. Okay, so can you just write anti sublimation, for example, mothballs? Mothballs. Okay, so these substances that undergo sublimation, they bypass melting and boiling. They go from solid immediately into gaseous state. Okay, because of certain properties of the substance. Once everyone is done writing the model, please let me know. Then we'll quickly move on to the next couple of concepts. All right, guys. Is everyone done?
Yes. Yeah.
Yes, Zakia, done.
Yes.
Okay, so chemical change. Let me run through the next sections pretty briefly. Chemical change. Okay, a change through chemical reactions of decomposition, combination, combustion, or oxidation. Please underline these four different words: decomposition, combination, combustion, or oxidation. Underline those. These are specific types of chemical changes. Next point, in a chemical change, the atoms of the reactants rearrange to form new products. Like what I said, they rearrange. They will, in a way, detach itself. Okay, some of the reactants might detach itself and then recombine to form new products. For example, hydrochloric acid reacts with sodium hydroxide to produce sodium chloride and water. For those of you who have watched my lecture, my part 1, part 2, you would know that this is neutralization reaction. Yeah, so please know that the substances before the arrow are called the reactants, and then the substances after the arrow, they are known as products. Chemical changes, they are permanent or very difficult to reverse. Okay, so we say that they are irreversible, very difficult to reverse. So looking at the table, I hope you're looking at the table, yeah. Okay, we can see that at the top, the labeling is light, heat, electricity, and mixing. What are these again? These are the things that bring about the chemical change. Okay, so for example, light. We have learned this before. A chemical change that occurs because there is light provided is photosynthesis. Photosynthesis is when plants, or the parts that contain chlorophyll in the plant, they will capture the light energy, okay, and they will convert carbon dioxide and water into sugar, okay, food for the plant. That is one example of a chemical change brought about by light. What else? Have you ever seen or not the old kind of cameras that use the film? Have you ever seen what it looks like, the film inside a camera? Have you ever seen it before, guys? I can't see you because my whiteboard is in the way. But have you seen that before? An old film camera?
No.
We would okay, so it's actually, right, a roll of film. So this film is like a plastic like material, but it is coated with substances that will change when it is exposed to light. Okay, so in the old fashioned camera, or like in the film cameras, right, the film roll, okay, the tiny part of the film roll will be positioned in front of the lens of the camera. So when you click the button, the camera will basically like open its aperture and let some of the light in. And the amount of light that enters the aperture of the camera, right, will be exposed on the film. Then the film will be exposed to light for tiny, like a split second. Yeah. And then it will basically capture the image of whatever that is in the view of the camera. I know that nowadays we are very used to digital camera, right? And the camera on our phone. But actually it works the same way. Because the camera in our phone, right, they have certain sensors that will sense how much light passes through its lenses. Okay, that is where we can obtain the image. But of course, don't make the misconception. Film camera and our digital camera, yes, light is involved, but for digital camera, no chemical reaction. It's only for film. Understand? Okay, I can't see you guys. So if you not, you have to like maybe just say something because I cannot see you all. Can someone just say yes if you understand? Okay, light, yeah, photosynthesis and film exposed on light. Is that clear to you all?
Yeah.
Yes. Okay, next one. Heat. Under heat, yeah, you have three types of chemical changes that can occur. Combustion. Whenever you hear the word combustion, you must remember, yeah, it is burning in air. Can someone tell me what are the various gases that are contained inside of air? What are the various gases contained inside of air? What does air contain?
Oxygen, carbon dioxide, nitrogen, hydrogen.
Yes, very good. Nitrogen is the largest proportion, the largest proportion of air. It is 78% inside of air. Okay, then the next we have oxygen, which is about 20%. And then we have other gases such as carbon dioxide and other rare gases, yeah. But when we're talking about combustion, please know this, yeah, guys. Combustion only actually involves oxygen. So can we write underneath the space substances burn in air? Specifically oxygen, because oxygen supports burning. So can we write this down? Specifically oxygen, bracket, supports burning. Yeah, specifically oxygen, which supports burning. So if substances burn in air, they are actually undergoing a chemical change specifically with oxygen, not the other gases. Okay, then the next one, they said is decomposition, right? A substance breaks down into two or more simpler substances. We usually use the term thermal decomposition because the word thermal suggests that it involves heat. Okay, so whenever you see questions, yeah, decomposition, they will usually specify that it is thermal decomposition. Okay, then the next one that also involves heat is oxidation. This is when oxygen is added to a substance with or without burning. Okay, added to a substance. So that means, for example, I'm going to give you carbon and oxygen, for example, and then we will get carbon monoxide. Okay, as you can see, carbon monoxide in terms of chemical symbol is CO, yeah? Okay, so to the carbon, which is just C, okay, one oxygen atom is being added to the carbon to form a new substance. Okay, carbon monoxide. So this is one example of an oxidation reaction. Okay, and by the way, the chemical formula of oxygen is O2. Okay, it is a molecule. It's a molecule that consists of two oxygen atoms like this. Okay, and since it's the same kind of atom, they should also be roughly about the same size over here. Okay, under electricity, electrolysis. You might not know what it is, so I will get you to write this down. Under electrolysis, yeah, can you write down breaking down a compound using electricity? So we are actually using electricity, okay, to break down a compound into simpler substances. Okay, that is what electrolysis is, breaking down a compound using electrolysis. Okay, Is everyone done writing this down? Electrolysis, breaking down a compound using electricity. Okay, guys, are you done writing?
Yeah.
Yes.
Okay, now moving on to the next last one, mixing. Mixing is just basically combining. Yeah, combining different substances together and maybe even stirring it. Okay, and then when this happens, the chemical reaction will happen, and then we'll get different a new substance, okay, which is the product. Okay, moving on, then we have a chemical equation. A way to summarize a chemical reaction by showing the reactants involved and the products formed. A chemical equation shows the total atoms of the reactants and products are conserved. Conserved meaning to say the total number of atoms before the chemical reaction and after the chemical reaction must be the same. To conserve, that means to save, okay? The number must be the same before and after the chemical reaction. Okay, next one. We are moving on to the whole thing about acids, alkalis, neutralization. Yeah. Okay, very briefly, characteristics of an acid: sour taste, able to conduct electricity, turns blue litmus paper red, can react with metals, carbonates or alkalis, and certain common acids, sulfuric acid, nitric acid, and hydrochloric acid. Okay, next page very quickly. Alkalis, the characteristics of an alkali: bitter taste, soapy feel, turns red litmus paper blue, and it is corrosive. Actually, to be honest, acids can also be corrosive, yeah, when it is at a very how do I say, at a very low pH. Okay, let me just stop presenting. Yeah. And then universal indicator. I've gone through in the lecture before. What is an indicator? An indicator is a substance that will change color when it is exposed to substances at different um, acidity or alkalinity. Okay, so there will be a color change, and that will tell us whether something is acidic or if something is alkaline. Okay, so if you were to use universal indicator, we follow the color of the rainbow. Can someone tell me if you know what is the spectrum of colors in universal indicator? Oh, sorry, what is the spectrum of colors in a rainbow starting from red? Does anyone know? Spectrum of colors in a rainbow. Red, and then what's the next color after red? No one knows the spectrum of colors? Okay, it's okay. I want you to write down R in capital letters, yeah? Can you just write down perhaps under the last sentence, under the it is red in strong acids, pale green, the spectrum of colors. R for red. Okay, don't have to write red, you just write the capital letter R. And then O. Can someone tell me what O stands for color? What is a color
Orange.
that starts with O? Orange, okay. And then the next one, write Y. Anyone can guess what Y stands for? Zakia, is the color of that swimming board behind. What is the color of the swimming board behind there in your room?
Yellow.
Yes, Y for yellow. Red, orange, yellow. G. What is the color that G stands for? You see a color that starts with G?
Green.
Green. Okay, so red, orange, yellow, green. Then B. What is the color that starts with the letter B?
Blue.
Blue. And then V. V stands for violet. Okay, and then the last color in this spectrum is purple. Okay, so ROYGBVP. That is the spectrum of colors in the rainbow. So please make sure you write it down. ROYGBVP, spectrum of colors. And this corresponds with like the colors of the pH range. Red is very strong acids. Orange, yellow, they are acidic, but they're not as strong as red. Okay, green tells us that a substance is neutral. It is neither acidic nor alkaline. Okay, and then blue is weakly alkaline. And then once you have violet and purple color, that tells us that it is a strong alkali. Okay, so it is a spectrum of colors and also corresponds with the acidity or the alkalinity. Okay, if it is in the middle, which is the color green, it would then be neutral. Okay, at this point, is everyone clear?
Yes.
Okay, now I'm going to move on to some slides just to recap also, yeah, what we had gone through in the lecture video. Once I'm done with this lecture video, we are going to take a look at some questions together. Okay, so all these things we had gone through already. So please remember, okay, the number of atoms and the mass of the atoms must be conserved, yeah, before and after the reaction. Okay, this is what we had gone through. Okay, combustion. Carbon burns in oxygen to form, for example, carbon dioxide. Okay, this is an example of a combustion reaction. Okay, then acid reactions, yeah. So we had just literally recap what acids and alkalis are. Okay, so I also explained to you that when we have, let's say, gastric pains, who can remember in our stomach, right? What is the name of the acid that is being released in our stomach? Does anyone know what is the specific acid that is released in our stomach? It is somewhere here on the slides if you look carefully. Can someone, you can see my screen, right? Do you see my slides?
I don't see your screen.
Oh, you don't see my screen. Hold on. Something wrong with the... Okay, you should be able to see something now. Can you see my screen?
Yes.
Yeah.
Yes? Okay, right. Yeah, this whole thing about the N acid. Okay, guys, is somewhere on the slides. What is the name of the acid that is secreted in our stomach?
Gastric juice.
Gastric juice, but what does gastric juice itself contain in terms of acid? Abdullah, can you read this one out? I'm pointing it out.
Hydrochloric acid.
Hydrochloric acid, yeah, hydrochloric acid. So in our stomach, yes, we will release gastric juice, and inside the gastric juice contains hydrochloric acid, which, by the way, yeah, is a very strong acid. Okay, so the reason why our stomach releases acid is to kill any foreign bodies or bacteria that can harm us. Okay, that is to keep us from getting like food poisoning and things like that. But sometimes our stomach might release too much gastric juice, and then when too much gastric juice is secreted, there will be too much hydrochloric acid in our stomach. That is the thing that causes the pain of gastric pain. Okay, so we want to remove the hydrochloric acid, excess hydrochloric acid, so to relieve the pain of gastric pain, and we can do this by consuming an acid tablets. Okay, so I have gone through that. Yeah, there are many different applications of using acids. Yeah, for example, in car battery, sulfuric acid is used in car batteries, and then hydrochloric acid can be used to maintain and clean our cars, to remove rust on iron and steel. Okay, and then some of you who had watched the part 2 video, you would have learned of this example, yeah, that we can use metal and wax, and then we can dip it inside a bowl of acid to etch, okay, to etch a pattern onto the metal. Okay, so whenever you see artwork like this, right, they are not, sometimes they don't use it, they don't carve it by hand, they are using acid. Okay, so because the acid will react with the metal, and then the parts that are covered by wax, it will not react with the metal. Okay, this allows us to make very intricate patterns on metals, which can be very difficult to handle. Okay, so Zakia, can you read this chemical equation out loud? Dilute acid plus metal will get us...
Dilute acid plus metal will get us salt and hydrogen.
Yes, dilute acid and metal will get us salt and hydrogen gas. Just checking with everyone. You have learned this before in school, right? Have you learned this already in school? Abdullah and Zakia,
Yes.
learn already?
Yeah.
Okay.
Yeah, but like
Abdullah?
I don't like understand a bit.
Okay, what is it that you don't understand about this reaction?
Like I don't understand like the chemical equation all.
Okay, guys, what is a chemical equation? This chemical equation, right, tells us what will happen if I add dilute acid and metal. Abdullah, you know what an acid is, right? At this point, it's a substance
Yeah.
that is, yeah, like sour, it has a pH of less than 7, things like that. So if I were to add metal and acid together, okay, if I put it together in, like, for example, a beaker, and then let's say I stir it, a chemical change will happen. So this arrow here tells us that a chemical change will happen. What are the two products here? Abdullah, can you read out loud? What are the two products here?
Salt and hydrogen.
Yeah, guys, this salt here, are they just talking about the table salt that we eat and we use in cooking? Is it that kind of salt?
No.
No. Okay, so in chemistry, right? Okay, this is where you have to start to learn the terminologies. Salt doesn't mean the salt that we eat, even though the salt that we eat, table salt, is an example of a salt. It is sodium chloride. But now in chemistry, right, salt is a group of substances that is formed between a metal and another component. Okay, so it's just, you just know that salt is a classification of a certain type of substance. Okay, and then hydrogen. What is hydrogen? Hydrogen is a kind of gas. Okay, it's a H2 gas. So this you have to memorize. Okay, the three kinds of reactions involving acid, everyone must memorize. Okay, so again, Abdullah, can you read this out loud? Dilute acid plus.
Dilute acid plus metal equals to makes salt plus hydrogen.
Yeah, don't, yeah, good, you corrected yourself there. Don't say equals to, yeah, because this is not an equal sign, this is an arrow. Okay, so you say dilute acid and metal will get us salt and hydrogen. Okay, there's I said three, right? So the second one is that acid can react with carbonates. Okay, so how many of you have helped your parents or helped your mom baking in the kitchen? Have you all ever baked before?
Yeah.
Yes. Zakia, Rizky, have you baked before?
Yeah.
Yeah.
For
Then
SG.
okay. Oh yeah. Oh, okay. So have you ever seen this substance here called baking soda?
No.
Baking soda? No. Abdullah, Zakia, have you seen or not baking soda?
Yeah.
Yeah.
Yeah. The purpose of a baking soda, soda is not the soda drink that we like to drink, like Coca-Cola, Pepsi, 7-Up. No, it's not that kind of soda. Okay. Baking soda or baking powder is a substance that allows our breads, our cakes, our pastries to be very fluffy. Okay, Zakia, can you do us a favor? Can you read what you see in this box over here? Number one, baking powder.
Baking powder is added to soured milk. This is added to the dough before baking. Baking powder contains carbonate while soured milk contains an acid. When the acid reacts with the carbonate, carbon dioxide is produced.
Okay, thank you. So they said soured milk. We learned that acids, they have a sour taste. So soured milk means they perhaps fermented it slightly such that there is a tiny bit of acid inside the milk. And like what they said, baking powder contains a carbonate, okay, which is a different kind of substance. It's not a metal, it's a carbonate. So acid and carbonate will react together. Okay, then what will happen? Rizky, can you read point number 2?
The carbon dioxide produced is trapped as air bubbles in the dough. The bubbles of carbon dioxide expand during heating, causing the dough to rise.
Yes. So for those of you who have baked before, you know, right, that after you have combined the dry ingredients and the wet ingredients, you have to allow the dough to rest, right? Who knows what will happen when you allow the dough to rest for, let's say, 20-30 minutes? What will happen to the dough? Anyone have any idea? when we allow dough to rest, it is actually going to expand in size. How does it expand in size? Because again, the baking powder, the carbonate, and the acid inside the sour milk, it will react and carbon dioxide is produced. You see what kind of substance is a carbon dioxide?
Gas.
It's a gas. So if gas is produced, right, and then it is within this very dense substance, the very dense dough, the carbon dioxide produced is going to be trapped within the dough. But what is going to happen is that the dough will then increase in volume, increase in size. And inside the dough is tiny, tiny air pockets, pockets of carbon dioxide, bubbles of carbon dioxide. Okay, so causing the dough to rise. So dough to rise means the volume of the dough increases. Is that clear? Can everyone?
Yeah.
Okay. So when we bake the dough, right? When we bake it, when it's being cooked and now it is edible, that is why the bread can be very fluffy and very soft because of all of these bubbles of carbon dioxide. Of course, when we bake it and when we eat it, when we tear the bread, the carbon dioxide will basically leave the bread. So we are not actually eating the carbon dioxide, lah, right? It's just that the carbon dioxide creates the bubbles, creates some like fluffiness to the bread. Okay, so that when we eat it, it's very soft and fluffy. Okay, so Abdullah, can you read this? This one is the second kind of reaction that you must remember. Can you read this out loud?
Dilute acid plus carbonate makes
So get us.
salt plus carbon dioxide plus water.
Yes, this is different from the first reaction. Who remembers the first one? Rizky or Zakia, do you remember the first one about dilute acid and metal?
Salt and hydrogen.
Salt and hydrogen. So what is different and what is in common? Dilute acid and carbonate and dilute acid and metal, both of them will produce salt. Okay, it's just that metal will produce hydrogen, whereas this here will produce carbon dioxide and water. Okay, so the gas that is produced is different. And of course, this one here will also produce water. Okay, so far we have learned two different chemical reactions involving acid. Now there's a last one that involves alkalis. Okay, but let's go through first. What are alkalis? Alkalis are also found in many things around us. They have a bitter taste and a slippery feel. So that's why alkalis, they are used in soaps and liquid detergents, yeah, to clean grime and dirt and dust from our clothes, from our skin, from our hair. Okay, so Zakia, can you have to read this? Sodium hydroxide is?
Sodium hydroxide is used in making soaps and detergents.
Carry on.
Ammonia solution is used to make fertilizers.
Yeah. Okay. So all of these are examples of alkalis being used in everyday situations. Okay, so the third kind of reaction is specifically called neutralization. Yeah. The other two, acid and metal and acid and carbonate, they are not neutralization. Neutralization is only for this one, when when alkalis react with acids. Okay, this is the specific name for this kind of reaction. So, for example, toothpaste contains an alkali which reacts with acid formed when bacteria acts on food particles on our teeth. Yeah, I went through this last week, but please know, yeah, that your mouth is actually quite is a breeding ground for a lot of bacteria actually, and this bacteria will eat on whatever remaining food that is left on our teeth. And when too much bacteria accumulates and a lot of acid is being released and formed, that can actually cause problems with our teeth, right? Things like plaque or tooth decay. So it's very important for us to prevent this. So we use toothpaste, which contains alkali. Okay, Abdullah, can you read this out loud? When the alkali?
When the alkali reacts with acid on our teeth, salt and water are produced. The acid is neutralized by the alkali to prevent tooth decay.
Tooth decay, yeah. Okay. So many neutralization can benefit us, yeah. So this is the third kind of reaction, alkali and acid will get us salt and water. And this is called neutralization reaction. Okay, so as a summary, okay, here we learn about acids and alkalis. They can react with metals, they can react with carbonates, or acids and alkalis can react together to undergo neutralization reaction. If you have acid and metal, what will we get? Salt and hydrogen gas. If you have acid and carbonate, we will get salt, carbon dioxide gas, and water. If we have acid and alkali reacting together, we will get salt and water. Okay, so you need to be able to answer these four questions. Yeah, the three reactions involving acids, examples of acids that we consume or use in our everyday life. Okay, and the name of the reaction between acids and alkalis, which is neutralization, and how to apply acid reactions. Many different things. Things like metal etching, things like taking N-acid tablets for gastric pain, things like using baking soda and soured milk to bake bread. Okay, many different examples of acid reactions. Okay, at this point, everyone clear? Do you understand? Yes? Okay, so now for those of you who attended class last Saturday, I had assigned homework, right? Can someone tell me please what are the questions that I assigned for you? It was just MCQ questions from what I remember. So what are the questions for MCQ? Zakia, do you recall?
I think it was question 6
Uh-huh.
and 22, 23, 24, 25.
Okay. Rizky, Zakia, 6, 22, 23, 24, 25, right?
Yeah.
Okay, did you guys manage to do that? The homework? Zakia, Rizky, do you manage to do? If you didn't do, we'll take the time to do now. Have you done it yet? Or haven't yet?
No.
Rizky, what about you? Have you done it yet? Not yet. Okay. Abdullah, I want you to check for me. Look at page 205. We haven't done any questions yet, right? Not yet, right?
Yep.
Zakia and Rizky, how many questions did we do for the MCQ?
We did questions 1 to question 5.
1, 2, question 5. Okay. So I think we can take the time to do questions now. Can you okay. Everyone basically make sure you do question 1 all the way until question 9. Okay, so circle first. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1 to 9. And then I won't go through 10 and 11 yet. So 1 to 9, and then turn to page 208. After that, then you do 21, 22, 23, 24, 25, 26. I repeat again. Question MCQ 1 to 9, and then 21, 22, 23, 24, 25, 26. Everyone got that? Yes? Got that, yeah? So how many MCQ questions are there in total? Can someone count? How many MCQ questions is that in total, guys?
15.
15, yeah. So 15, I think 15 minutes would be enough, 1-5. Okay, so please start now. And then at 10:05, we will run through. Sorry, I muted myself. Do write down your answers also, because later on I will have you to send me your answers. Rishi, please sit properly because this one is recorded, yeah. So yeah, just make sure you sit properly. Rishi, you seem that you are done already, is it? Are you done already? Done. Zakia and Abdullah, are you done already?
Almost.
Almost. Okay, Abdullah.
I have about 5 more questions left.
Okay, can. So I'll give everyone, yeah, just maybe a few more minutes, yeah. Then maybe by 10 we can run through already. Okay, guys, is everyone done? Can we run?
Yes.
Abdullah, can we run
Yep.
through? All right. So just so that we recap again and for Abdullah's benefit, yeah, can we run through from the first question again? Rishi, please read question number 1 for us. Which statement? Question number 1, MCQ 1.
Which statement is not correct about the thermal decomposition of calcium carbonate? Is it a chemical change caused by the effect of heat? The new products formed after decomposition, the total mass of the products after decomposition is less than that of the reactants. The products are formed by the arrangement of the atoms in the reactants.
Okay, so this books always likes to ask what is not correct, not correct. Okay, so please, whenever they ask you this kind of trick question, can you please circle the not? Okay, so that you know to select the incorrect statement. All right, so I think this one is pretty easy. What is incorrect about chemical changes, specifically about thermal decomposition? The total mass of the products after is less. Remember, there must always be a conservation. The number of atoms and the mass of the products must be the same as the mass of the reactants. Okay, so that's why the correct answer would be option C. Okay, let me just share my screen so that you can see any stuff that I want you to write down. Should be able to see a whiteboard in a bit. Question number 2. Okay. By the way, question number 1, the answer is C. Is everyone clear? Kenya? Question number 2, Zakia, can you help to read for us, please? Which of the following?
Which of the following statements are correct about a physical change? I atoms of the reacting materials rearrange. I the change can be reversed easily. I the physical and chemical properties of the substance remain the same.
Okay, correct about physical change. Whenever they say physical change, we are talking about changes in states. Okay, we are not talking about the formation of any new product. So there will not be any rearranging of atoms. So any option with the first one is eliminated. So can you tell me if the first statement is eliminated, what option can we eliminate already? If statement 1 is wrong, what answers in the MCQ is therefore eliminated?
A, B, and D.
Yes. So guys, remember, yeah, MCQ is also about answering technique. Once you have elimination, right, you can already start to eliminate your answer. And if you do that, you will already get the correct answer, which is option C. Okay, so some people, when they do the MCQ, they don't think about the strategy. So please take note also that MCQ has a answering strategy. Okay, next question I will read. So please pay attention. In an experiment, potassium chloride crystals are dissolved in water as shown below. They put the crystals inside water. The initial temperature is 25 degrees Celsius. After dissolving, the temperature of the potassium chloride solution is 18 degrees Celsius. There is a change in temperature. Okay, so if there's a change in temperature, specifically the temperature decrease, this actually tells us, right, that this reaction requires energy. They are taking in heat energy from the water. After the crystals have dissolved, the temperature decreases. Which conclusion is the most appropriate from this observation? Dissolving a substance always causes a chemical change. Heat is involved when potassium chloride crystals dissolve in water. A chemical change always leads to a change in temperature. Physical change releases heat into the surroundings. The only statement that makes sense here that we can say correctly is actually statement B. Heat is involved. Why is heat involved? Because heat is taken in from the solution. That causes the decrease in temperature. It doesn't mean that there's a chemical change. This one is just dissolving. Okay. Does it always leads to a change in temperature? Not all the time. For this specific case, yes, but not for all cases. We cannot say definitively. Okay, and then releases heat. Is this releasing heat? No, this one is actually taking in heat because the temperature decrease. Okay, so the correct answer would be option B. Now, what is the next question that I asked you to do? Question 4, right? Is that question 4? Yes, right, guys?
Yeah.
Yes, can someone confirm? Yeah, question 4. When pure aluminium Al is exposed to air, it combines with oxygen to form aluminium oxide, Al2O3. These, by the way, are the chemical formulas of substances here. The chemical reaction is shown below. So the chemical reaction that you see there will tell us, okay, will tell us how many atoms of aluminium, how many molecules of oxygen, and how many molecules of aluminium oxide will be formed. Tell me, do you remember just now there was a question? The mass and the number of atoms must be the same before and after the chemical reaction. So if you're to count the number of atoms of aluminium before and after, number of atoms of oxygen before and after, they will all be the same. Can someone tell me what is the number in front of Al on the reactant side? What's the number in front of the Al? In the chemical equation, what's the number in front of the Al?
4.
4. What is the number in front of the O2?
3.
3 and then O2. Guys, look at my whiteboard, yeah. 3 and then the O2. How do we count the number of oxygen atoms? You look here very carefully. There are 3 molecules of oxygen. One molecule is 2 oxygen atoms. If I have 3 of this, how do I calculate that number of atoms? 2 times 3. There's actually 6 atoms. You all understand? 6 atoms of oxygen, 4 atoms of aluminium. Yeah? Is everyone clear on this? Yes or no? I can't
Yeah.
see you guys, so yeah, you need to say 4
Yes.
atoms of aluminium and then we have 6 atoms of oxygen. After the arrow, Risky, tell me, 2Al, 2O3. How do I count? 2Al2 and then O3. How should I count the number of aluminium atoms here? Over here. How do I count? How many aluminium atoms? Risky, are you there?
2.
Why 2? There's a number 2 here, but they said that there's 2 here. Then how? Whenever you see something like this, right, you must remember, okay, for example, you know in maths, there is this thing, right? Correct? You remember when in maths, when you expand the bracket, the 2 have to apply to the x and to the y. Agree? In maths? Yes or no, Rizky?
Yes.
So you apply the same principle to chemical formula. The 2 has to be applied to the Al2. So in terms of Al, how many then? 2 times 2, right? Which is equals to 4. You understand that, Risky? Yes?
Yes.
Then what must the 2 be also be applied to? To the O3. So if the 2 is applied to the O3, it will be what? 2 times 3. 2 times 3 is equals to
6.
6. So do you see before and after the reaction, the total number of aluminium atoms and oxygen atoms, they are the what? They are the same or different?
Same.
They are the same. And this demonstrates that what? The number of atoms and the mass of atoms have to be conserved. Okay. By answering the question, which statement is not correct? Make sure you circle the word not. What is not correct? Is this thermal decomposition? Automatically, the answer is A, because this is not a decomposition. Decomposition is when we break down a compound into simpler substances. This is actually the opposite of thermal decomposition because we are taking aluminium, oxygen, combining them to form a compound. Okay, so the answer is option A. Question 5. Bread with patches of mold growing on it. Which of the following is not suitable? Again, circle the phrase not suitable. Okay, bread and mold. Can someone tell me, bread and mold, are they the same substance or are they different substance?
Different.
How do we get mold? Zakia, any idea how we get mold? What is mold? Yeah, remember from primary 6. What are mold? What is mold? It's actually type of, what is this? What did I just type out?
Fungi.
Fungi. And fungi likes to grow in what kind of condition? Remember? Fungi likes to grow in damp and dark conditions. So tell me again, the mold and the bread, are they different substances, different things, or the same thing? Obviously different, right? Okay. And the reason why fungi forms is because some of the fungi spores in air, they will latch onto the bread. And under the right conditions, they will feed on the bread and then more fungi will grow, causing the mold to form. Okay, so what then happens? The bread undergoes a chemical change, right? Because the bread will basically like be rotting and the fungi and the mold gets to what do you call that? Oh, but they're asking for not suitable. Okay, so bread undergoes chemical changes is not the right answer. Atoms of the bread have arranged also not the answer because it's a correct statement. New products are formed from the bread caused by the presence of mold. This is also true. So for question 5, the correct answer is C. This is not a physical change. Remember, physical change has to do with the different physical properties. Abdullah, understand?
Yes.
Okay, Abdullah, can you read question 6 for us? Question 6.
The following diagram shows the process electro, elect, electrolysis,
Electrolysis.
electrolysis of water. Which of the
Okay.
following cannot be concluded from the electrolysis of water?
Okay, no. Now I want you to write several things. Can you write above water? This is the formula of water, which is H2O. And also circle, cannot be concluded. So we know that electrolysis is when we use electricity to break down substances. So this water H2O will be broken down into hydrogen, which is H2, and it will be broken down into oxygen, which is O2. Now, if you are concerned about the number of atoms, this is how it works. Yeah? We put a 2 over here, and then we will actually have 2 molecules of H2, and then we have 1 molecule of O2. Okay, so can you please write this down somewhere so that you know how it works? In terms of chemical equation, please also write this down. 2H2O, okay, nothing else. Long arrow, and then above the arrow, write electricity, because this is an important condition. And then the two products would be, therefore, the 2H2 and then your 1 oxygen molecule. Is that okay? You all understand?
Yeah.
Okay, quickly write this down. Okay, so cannot be concluded, yeah. Water is a compound as it is made of two different elements. Okay, oxygen and hydrogen, they are two elements, and this is true. Okay, so we don't choose A. After electrolysis, the products have their own distinct properties. Yes, hydrogen and oxygen, they are gases, whereas water, okay, at room temperature is liquid. So they have their own properties. So B is not the answer. C, electricity can break down water molecules into different elements. This is also true. D, a physical change takes place when water in liquid state changes into oxygen gas and hydrogen gas. This is wrong because it is not a physical change, it is a chemical change. Yeah, so therefore we select option D. Is everyone clear? Is that clear, Rizky? Clear?
Yes.
Okay, now I'm going to move on very quickly because we only have 15 minutes left. Okay, question number 7. Statement is not correct about melting of a substance. What is melting? When we go from solid to liquid. What kind of a change is this? This is a physical change. Yeah, again, they are looking for not correct answer. A, change is temporary and reversible. This is true, not the answer. The mass of the substance remains constant after the change. This is also true, not the answer. The atoms of the substance rearrange so that a new physical state can take place. Wrong. The atoms do not rearrange because this is a physical change. When atoms rearrange, there is chemical change. So answer for 7 is C. Moving on, which of the following is not an example? So you see, this book likes to ask not the example, not correct, not a conclusion. You have to be very attentive. Circle the word not also. Okay, not an example of mixing substances which leads to a chemical change. Adding sulfuric acid to sodium hydroxide solution. Acid and sodium hydroxide. Can you please underline the sodium hydroxide? And you write on top of the sodium hydroxide, alkali. Can someone tell me what is the name of the reaction when we react acid and alkali together? What is the name of that reaction, Whiskey? Name of the reaction when we add acid and alkali?
Neutralization.
Yeah, so this is neutralization. Neutralization is a chemical change. So A is not the answer. Okay. B, placing a piece of magnesium in nitric acid solution. Who remembers? Magnesium, you can write above magnesium. It is a metal. Who remembers? Metal and acid will get two things. What are the two things?
Salt and
Acid.
hydrogen.
Very good. And is that a chemical change? Yes, it is. So not the answer. Next one, dissolving sodium chloride crystals in water. Dissolving is not a chemical change because we can actually get back our crystals. It's a reversible reaction. Therefore, the answer is C because it's not a chemical change. Last one, calcium carbonate and hydrochloric acid. To recap again, acid and carbonate will get us three things: salt, water, and carbon dioxide gas. Okay, next one, question 9. Which of the following is not an example of chemical changes involved heat? Okay, not, again, another not question. Okay, so what do we have here? Formation of iron sulfide when iron combines with sulfur. This here, chemical combination will involve heat. A is not the answer. Formation of sugar when carbon dioxide combines with plus. By the way, this one, right? Formation of sugar when carbon dioxide combines with water in plants. This is photosynthesis. Can you please write down beside this statement? Photosynthesis. Photosynthesis does not involve heat, but it involves light. So write this down. Photosynthesis bracket involves light. And if you know this, then B would be the answer for question 9. Okay, the rest involves heat. Okay, formation of carbon dioxide when a candle is lit. This is combustion. Formation of black carbon when sugar is decomposed. This is thermal decomposition. C and D involves heat. Okay, so it's just B. Photosynthesis doesn't involve it. It involves light. Okay, is that clear to you guys? All clear?
Yes.
Okay, next one is question 21, right? Yes, 21. When a blue litmus paper is placed in solution X, it remains blue. Which of the following cannot be solution X? Okay, now I didn't go through this just now, but for those of you who watched my videos last week, you would have known, you have learned this. Blue litmus paper, yeah, when it comes into contact with acid, tell me, the color will change from what to what? Blue litmus paper. Who remembers this? Blue litmus paper and it comes into contact with acid. What color will it change to?
Red.
Red. And then red litmus paper, when it comes into contact with alkali, what color will it change to?
Blue.
Blue. Then tell me, if blue litmus paper remains blue, two possibilities. What are the two possibilities?
There's a pH level of 7 or neutral, or it's alkaline.
Yeah, because alkali for litmus paper carries the color blue. But sometimes also if it is neutral, it won't change the color. Okay, so if blue litmus paper remains blue, it can mean that it is either water or alkali. But again, yeah, they are asking us cannot be solution X. It definitely cannot be acid. Because if it is acid, the blue litmus paper will turn red. So the answer is B. Can? Okay, next one, quick 22, right? Then it's the next question. Which of the following is not correct about an alkali? It is found in detergents. This is true, not the answer. It gives a red color when universal indicator is added to it. This is false because I told you already, right? Colors of the rainbow. Someone tell me again, what is the spectrum of color in the rainbow? Starting from red.
Red, orange, yellow, green, blue, violet.
And purple. Okay, so if you're talking about the colors associated with alkali, is after green. Okay, so you're talking about blue, violet, blue, purple. So red color is not it, yeah. So B is the answer for 22. Okay, very quickly, we only have 7 minutes left. 23. Study the descriptions of solid X. Soapy feeling when dissolved in water can only conduct electricity when dissolved in water, gives out a large amount of heat when react with acid. When you look at the soapy feeling, you should already know that it's referring to alkali. Okay, the only alkali here is option C, because A is a carbonate, iron and aluminium, they are metals. The only base here, sorry, the only alkali here is sodium oxide. Okay, option C. 24. Reaction between dilute hydrochloric acid and magnesium. Please someone tell me, magnesium is a metal, a carbonate, or an alkali? What is magnesium?
Metal.
Yes. So guys, whenever you see the element name only, okay, this should tell you that it is only the, because if it is an alkali, it will be a something hydroxide. If it is a carbonate, you see in the name, it's a something carbonate. Okay, and again, acid and metal will get us salt and hydrogen gas, right? Okay, so magnesium and hydrochloric acid. Hydrochloric acid will provide, right, chloride to the salt, because hydrochloric acid is this back part of the acid, the Cl, the chloride here, will be part of the salt. So the salt that is formed, right, will be magnesium and the chloride. So taking together, magnesium chloride is therefore the salt. Okay, so magnesium and hydrochloric acid will get us magnesium chloride and hydrogen gas, which is option D. Okay, is everyone clear? Yes?
Yes.
Yeah.
Okay, 25. Color change of 3 indicators. Now, please take note, yeah. PQR are totally different indicators from litmus paper and from universal indicator. There are other substances. Okay, and then for P, Q, and R, there are certain colors that it will change at a certain pH level. So for P, right, before the pH 4, it is red. After pH 4, it is yellow. For Q, before 5 is blue, after 5 is red. For R, before 9 is colorless, after 9 is red. Pure water. Tell me guys, pure water, is it acidic? Is it an acid? Is it an alkali? Or is it neutral?
Neutral.
So pure water, it is neutral. So basically tell me what is the pH of neutral?
7.
Yes, so it is pH 7. So you just need to identify where is 7. 7 for P, it will be yellow. 7 for Q will be red. 7 for R would be colorless. So yellow, red, colorless. Yellow, red, colorless would therefore be option B. Yeah? Is everyone clear on that? Option B. Okay, pure water is neutral. Yeah, if you don't know, please make sure you write this down. Is 26 the last question, guys?
Yes.
Okay, when potassium hydroxide reacts with dilute hydrochloric acid, the reaction is called. So remember what I said. Whenever you see something hydroxide, this is your alkali. So can you please write above potassium hydroxide now that this is your alkali? So again, acid and alkali, what is the reaction called? Someone? What is the reaction called? Acid and alkali?
Neutralization.
Neutralization, which is option B. Okay, is that clear for everyone? Is that clear for everyone?
Yes.
Yeah.
Okay, let me just stop my recording here.